Dear students, I am Dr. Tamrakar from Bhartiya College of Agricultural Engineering, Durg. I will teach theory of machine of BTech first year, second semester class. Dear students, today we will discuss types of joints in a chain. The following types of joints are usually found in a chain. First is binary joint, when two links are joined at the same connection. Here A is one connection, B is connection, C, D, these joints are connection, and here two links are joined, one link and four. In B, 1 and 2 are joined, C, 2 and 3 are joined, and at point D, 4 and 3 are joined. So here 4 links and 4 binary joints A, B, C, D are formed. Here this binary joint follows one relation, J plus H by 2 equal to 3 by 2 L minus 2, where H is number of higher pair, J is number of joints, and L is number of links. If we see here, if the number of higher pair H equal to 0, here both are lower pair, all are lower pair, so H equal to 0, then this equation becomes J equal to 3 by 2L minus 2. Now putting the values of number of joints here, 4 joints, number of links, 4 links, so 2 to the 4, 6 minus 2 means 4. 4 equal to 4, that means left hand side is equal to right hand side. So this is kinematic chain or constraint chain. This ABCD, this link is a kinematic chain or constraint chain. Here all binary joint, all joint ABCD, all are binary joints. So this type of machines we can see in our machine lab or in the industries also. Okay. Next is ternary joint. When 3 links are joined at the same connection, if some connections are there where 3 links are joined at the same joint. Okay, we can see this example here. This is A, B, C, D, E. Here the joints links are 1, 2, 3, 4, 5 and 6. These are the links here. So here A, B, C, D are binary joints. A, 2 links are there, B, 2 links are there, and D, 2 links are there. So these are binary joints. These are binary joints. A, B and D are binary joints. Okay. Then C and E are ternary joint. Here at point C, 3, 5 and 2, 3 links are joined. So this is ternary joint. And at point E also 3 links are joined there, 4, 5 and 6. So E is also ternary joint. So in this link, this joint, 3 links are connected at E and C. That are ternary joint. And 2 links are connected at A, B and D. Okay. One ternary is equal to 2 binary joints in a chain. If we want to replace this E and C with equivalent binary joint, then this can be replaced by 2 binary joints. One binary joint is 6 and 5 and one binary joint is 5 and 4. Similarly, at point C also at ternary, these higher pairs can be replaced, ternary joint can be replaced by binary. This 2 and 5 is one binary and 5 and 3 is one binary joint. So here equivalent binary joint in this chain, number of binary and ternary have 2 binary joints. So here 3 binary joints and 2 ternary joints. So this is 4 plus 3, 7. Number of binary joints in this question is 7. And here L equal to 6, number of links are 6 and number of joints are 7 as we have calculated here. These are 7. So in equation when putting the values j equal to 3 by 2 L minus 2, where j is number of joint and L is number of link. Putting the values here, joint 7, 3 by 2 L is 6, so minus 2, that is equal to 7. 2 3 are 6, 3 3 are 9, 9 minus 2 is 7. Okay, so here left hand side is equal to right hand side. So this chain is a kinematic chain or constraint chain. Okay, this one is kinetic chain or constraint chain. Next type of joint are quaternary joint. Here 4 links are joined at same connection. In one direction 4 links are joined there. The joint is called a quaternary joint. Generally, if L is number of links are joined at the same connection, the joint is equal to L minus 1 binary joint. Okay, the joints are L minus 1 binary joint. Example, here in this figure, this is the example of quaternary joint. Here AB is one link, BC is second link, AC is third link, BD is fourth link, D is fifth link, EF 6, EG 7, GF 8, FC 9, CG 10 and GA 11. So 11 links are here. So here the binary joints are first single binary joint at point D. D only a point where binary joint 5 and 4, 2 links are there. Other are having more joint. Then ternary joints, here 4 ternary joints, A, B, E, F. A having 3, B having 3, E also having 3, and F also having 3. So they are ternary joints. And quaternary joints, here 2 that are C and G. Here at point C, 1, 2, 3, 4 and G, 1, 2, 3, 4. Okay, these are the quaternary joints. Now, one quaternary joint can be replaced by 3 binary joints. This we can see 3 binary joints. 1 binary, 2 binary, 3 binary, and 4th is the main one. Okay, so this is 3 binary joint. One quaternary can be replaced by 3 binary joint, and one ternary joint, as we know, is replaced by 2 binary joint. So here total joints are 1 binary joint and 4 ternary joint and 3 are quaternary joint. So putting the values here, this number of joints come 15. Here number of joints are 15, number of links are 11. Now putting in the equation, this equation j equal to 3 by 2 L minus 2. So j is number of joints are 15, 3 by 2 into L is 11 minus 2. So this is 15 and right side is 14.5. Here left hand side is equal to right hand side of the quaternary joint. So here left hand side is greater than right hand side. So this is not a kinematic chain. If the link CG is removed, then it has become different, like this. Here this kinetic chain has binary and ternary joint. Only binary and ternary joints are there. Okay, here GC is removed, so here it has 10 links. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Only 10 links are there. Here one binary joint at D, at point D, binary joint, and A, B, C, E, F and G, all other are ternary joint. This is ternary, 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 this is ternary. All other are ternary joint. So total number of joints are 1 plus 2 into 6, 6 ternary joint. That is equal to 13. Now putting in equation the values, J equal to 3 by 2, L minus 2, J is number of joint, L is number of link, 13 equal to 3 by 2, L is 10. So this is 13. Again, here left hand side is equal to right hand side. So this chain is a kinematic chain or constraint chain because here left hand side is equal to right hand side. Okay, here this GC link has been removed. So earlier that was quaternary and that was also quaternary joint. So when we removed this GC joint, the chain is a kinematic chain or constraint chain. Okay. Okay, dear friends. Next topic is mechanism. When one of the link of a kinematic chain is fixed, the chain is known as mechanism. Number of links are there in one kinematic chain. If we fix any one of the link, then this is called mechanism. Used for transmitting or transfer motion. This mechanism, one link is fixed for transmitting or transferring motion. As example, engine indicators, then typewriter, etc. are the example of this type of machine. A mechanism with 4 links is called simple mechanism. If any mechanism having 4 links, then this is called as simple mechanism having 4 links. When more than 4 links are there, then this is called compound mechanism. So if 4 link is there, then this is called a simple mechanism. If more than 4 links are there, then this is called compound mechanism. When a mechanism is required to transmit power or to do some particular work, here some particular work, okay, some particular work, some one link is fixed and other are free to work, okay. So when a mechanism is required to transmit power or to do some particular type of work, it is then become a machine. Means any machine has to perform some particular work or transmit power. So this is called a machine. When a mechanism is required to transmit power or to do some particular work, okay, so it is then become a machine. In such cases, various links or elements have to be designed to withstand forces. If a machine is there, a structure is there, a link is there, a mechanism is there, then number of forces are acting on that machine, on that link, on that structure. Okay, so the elements have to design to withstand forces, both static and kinematic. Static forces are different and kinematic forces are different. So in such cases, various links or elements have to be designed to withstand forces, both static and kinematic, safely. Okay. A mechanism may be regarded as a machine. अब जो mechanism है वो machine कब होगा? In which each part is reduced to the simplest form to transmit the required motion. ठीक है, नंबर ऑफ लिंक वहां पे अवेलेबल है. एक लिंक का काम है कि भाई वो जो रेसिप्रोकेटिंग मोशन होता है उसको वो सर्कुलर मोशन में, रोटरी मोशन में कन्वर्ट कर सके. ठीक है, मीन्स सिलेंडर हुआ, पिस्टन हुआ, एंड देन रॉड हुआ, देन क्रैंक हुआ, वो तीनों चारों मिलकर वो जो रेसिप्रोकेटिंग मोशन है उसको रोटरी मोशन में कन्वर्ट कर सके. तो अ मैकेनिज्म may be regarded as machine, तो मशीन हो जाएगा. in which each part is reduced to the simplest form. तो वो क्या है, डिफरेंट पार्ट जो है वो सिंपलेस्ट फॉर्म में उनको रिड्यूस कर देते हैं टू ट्रांसमिट द रिक्वायर्ड मोशन। तो जो भी उसको हमको रिक्वायर्ड मोशन चाहिए है उसको ट्रांसमिट करने के लिए उसको हम लोग बदल देते हैं। ओके, हियर नंबर ऑफ डिग्री ऑफ फ्रीडम फॉर प्लेन mechanism. In design or analysis of a mechanism, one of the most important concern is the number of degree of freedom. Number of degree of freedom. Okay. Number of degree of freedom of mechanism directly determined from number of link and number of type of joint. Number of link and type of joint, which it includes. Now here, if a 4-bar chain is there, L1, L2, L3, L4 are 4 link and joints are A, B, C, D, then this angle theta will depend. Here a little consideration, theta is needed to define the relative position of all the link. With this theta, the relative position of all other link is determined. So the number of degree of freedom of 4-bar mechanism is 1. That is theta. Okay. From theta we can change the other elements also. So the degree of freedom is theta. Similarly for a 5-bar chain, here 5 links are there and 5 joints are here. Theta 1 and theta 2 are the 2 degree of freedom provided here. Now, in this case, 2 variables theta 1 and theta 2 are needed to define completely the relative position of all other links. Thus, we say that the number of degree of freedom is 2. Here, this is a link in a plane motion. In order to develop relationship general, consider 2 links A, B and CD. We have considered only 2 links. AB is fixed and CD. In CD, any point P can be determined in the XY plane as this is X and this is Y. So here, to fix the link DC, CD, we have to find the point P, that is X and Y. 2 points are there, and the angle between AB and CD. These are the thing 1, 2 and 3. Due to this, the point, the link CD is fixed. The link AB with coordinate system OXY is taken as the reference link. The position of P on the moving link CD, this one is the moving link CD, can be completely specified by 3 variables. The coordinates of point P denote X and Y, and the inclination theta, this one theta angle of link CD with x-axis or link AB. Theta with the x-axis or link AB. In other words, we can say that each link of a mechanism has 3 degrees of freedom before it is connected to any other link. Okay, 1, 2 and angle, 3 degrees of freedom. Okay, but when the link CD is connected to point A, AB by a turning pair at A, यहाँ पे A पे turning pair बना दिया, CD को यहाँ पे A point पे D को कनेक्ट कर दिया, ये only theta, एक ही वहाँ पे आपको variable बचेगा. The position of link CD is now determined by a single variable theta and thus has 1 degree of freedom. तो इस केस में यहाँ पर 3 डिग्री ऑफ फ्रीडम है, एक्स, वाई एंड एंगल थीटा. उसको यदि हम इस CD लिंक को AB में फिक्स कर देते हैं, A पे पॉइंट D को एक टर्निंग पेयर यदि हम लोग बना देते हैं, तो केवल एक थीटा एंगल बस होता है जिससे उसको हम लोग डिफाइन कर सकते हैं। फ्रॉम अबव वी सी दैट व्हेन अ लिंक इज कनेक्टेड टू फिक्स्ड लिंक बाय अ टर्निंग पेयर से इसको फिक्स्ड लिंक में जब हम लोग ऐड कर देते हैं, जोड़ देते हैं, 2 डिग्री ऑफ फ्रीडम आर डिस्ट्रॉयड। तो एक्स और वाई ऐसे 2 डिग्री ऑफ फ्रीडम यहाँ पे आपके डिस्ट्रॉय हो जाते हैं। दिस में बी क्लियरली अंडरस्टूड फ्रॉम दिस फिगर, set of figures. This is a 4-link pair. Here one is fixed तो इसके 3 तो यहाँ पर डिग्री ऑफ फ्रीडम इसके 9 मिले। ठीक है, एक्स वाई निकालना पड़ेगा और एंगल एक्स वाई एंगल 9 हो गया। अब यदि ये 4 वाले लिंक को हम ए के साथ में जोड़ देते हैं, ठीक है, यहाँ पर केवल ये एक थीटा बचेगा। ठीक है, एक्स वाई कम हो जाएगा, मीन्स 2 डिग्री ऑफ फ्रीडम यहाँ पे कम हो जाएंगे। और बाकी ये इसके 3 3 6 और 1 7, यहाँ पर आपको डिग्री ऑफ फ्रीडम 7 मिल गया। सिमिलरली यदि हम ये सेकेंड लिंक है इसको भी अटैच कर दें ए बी के साथ में, तो यहाँ पर भी ओनली थीटा बचेगा। ठीक है, तो इसके 3 डिग्री ऑफ फ्रीडम, इसका 1, ये डिग्री ऑफ फ्रीडम यहाँ पर 5 बचेगा। ये सारे 4 बार मैकेनिज्म ही है जिसको डिफरेंट टाइप से हम लोग जो फिक्स लिंक है उसके साथ फिक्स करके उसके डिग्री ऑफ फ्रीडम फाइंड आउट कर रहे हैं। इसके बाद नेक्स्ट यहाँ पर बोल रहा है कि ये थर्ड लिंक है उसको भी ज्वाइन कर दिया, तब यहाँ पर भी केवल एक थीटा बचा, थीटा 1, थीटा 2 एंड थीटा 3। यहाँ पर इसका डिग्री ऑफ फ्रीडम 3 हुआ। इसके बाद देखें यहाँ पर आप इसको पूरा फिक्स कर दिए, चारों लिंक को फिक्स कर दिए, ये खाली एक एंगल बचा, यहाँ पर डिग्री ऑफ फ्रीडम n = 1 बचा। ठीक है, ये डिफरेंट टाइप के हैं जो 4 बार मैकेनिज्म में एक लिंक फिक्स करने से देन सेकेंड लिंक के लिए हम उसमें जोड़ दें तो थीटा बचता है और 2 डिग्री ऑफ फ्रीडम यहाँ पर कम हो जाते हैं। तो यहाँ पर दिखा हमने कि जो 4 लिंक है वहाँ एक फिक्स है तो 3 3 3 9 डिग्री ऑफ फ्रीडम, दूसरा फिक्स कर दिया तो 3 3 एंड 1 दैट इज 7 3 3 एंड 1 एंड 1। ठीक है, ये 3 3 6 और 1 7 बचे। यहाँ पर ये सेकेंड को फिक्स कर दिया तो यहाँ पे थीटा और थीटा 2 बचे और इसके 3 4 5 हो गया डिग्री ऑफ फ्रीडम। यहाँ पे हम चौथे लिंक को भी फिक्स कर देते हैं तो यहाँ पर केवल एक थीटा, इसका एक थीटा, डिग्री ऑफ फ्रीडम 3 बचा। यदि हम चौथे को भी फिक्स कर दें तो एक यहाँ पर थीटा डिग्री ऑफ फ्रीडम 1 मिल जाएगा। ठीक है, तो ये डिफरेंट प्लेन मोशन से लेकर ये लिंक को कैसे फिक्स करते हैं और उनके डिग्री ऑफ फ्रीडम में क्या चेंजेस आते हैं, इसी के हिसाब से डिफरेंट मशीन्स बनाए जाते हैं और उनकी वर्किंग फिक्स होती है। तो मोस्ट इम्पोर्टेंट है आपका थ्योरी ऑफ मशीन के चैप्टर में। नाउ लेट अस कंसीडर अ प्लेन मैकेनिज्म with L number of links. In a mechanism having L number of links, since in mechanism one of link is to be fixed. Okay, for making any mechanism a 4 bar link, any one link has to be fixed. So the number of movable link will be L minus 1. तो जितने भी मान लो 4 लिंक हैं तो 4 में से एक को फिक्स कर दिया तो मूवेबल कितने बचे, 3 बचे। L minus 1 3, 4 में से 1 माइनस कर दिया 3 बचेंगे। एंड दस द टोटल नंबर ऑफ डिग्री ऑफ फ्रीडम, तो डिग्री ऑफ फ्रीडम पहले क्या था, पहले था आपका 3 3 3 3, उस पे 1 माइनस कर दिया तो 3 इंटू L माइनस 1, सभी के डिग्री ऑफ फ्रीडम 3 होते हैं। ठीक है, और इंटू L माइनस 1 तो 3 इंटू L माइनस 1, L 4 लिंक है तो ये 9 बचेंगे यहाँ पर। दिस विल बी फॉर दे आर कनेक्टेड टू एनी अदर लिंक। एक लिंक को बस फिक्स किया, बाकी सबको फ्री रखा हुआ है। मान लो 4 लिंक हैं, 4 में एक फिक्स किया तो वहां पर 3 3 3 9, यहाँ पे आपका डिग्री ऑफ फ्रीडम 9 आएगा। इन जनरल अ मैकेनिज्म विथ L नंबर ऑफ लिंक कनेक्टेड बाय J नंबर ऑफ ज्वाइंट ऑफ बाइनरी ज्वाइंट। बाइनरी ज्वाइंट रहे मीन्स एक लिंक और एक लिंक केवल 2 लिंक जुड़े रहेंगे, वो बाइनरी ज्वाइंट होता है। ठीक है, इन जनरल मैकेनिज्म विथ L नंबर ऑफ लिंक कनेक्टेड बाय J number of binary joint means lower pair joint. Binary joint are called lower pair joint. Okay, that is single degree of freedom pair, then the number of degree of freedom of a mechanism is given by this formula n equal to 3 L minus 1 minus 2J minus H, where L is number of link, then J is number of joint, and H is number of higher pair. This equation is called Kullback's criteria for movability of a mechanism having plane motion. This equation is called. If there are no 2 degree of freedom pair, that is higher pair. If no higher pair is there, then H equal to 0. Substituting H equal to 0 here in equation 1, we will find equation 2, n equal to 3, L minus 1 minus 2J. Okay, so this Kullback criteria equation is developed here, and for lower degree of freedom pair, excluding the higher pairs, H equal to 0. So this equation become n equal to 3, L minus 1 minus 2J. Okay, depending on these equations, we will discuss some more questions in our next classes. Thank you. Thank you. You have to read these questions, and this chapter is the main basis of the theory of machine. All machines have been developed by using these basic fundamental rules of the machines. We have to fix one link and other links are movable. If you fix one link with the second link, the degree of freedom will be reduced by -2. Okay, this type of fundamental things are here that we should know before starting any type of making machine, and this is very important for the agriculture students, because agriculture engineering students should know which type of machines are developed and which type of machines are used, what is the concept behind this type of machines, and they can make or propose different new kind of machines for doing different type of works. Okay, you have to practice on this to develop new machines. Thank you.